Hey everybody, thanks for joining me. My name is Jacob Tomlinson, and on this stream I'm going to be trying to solve an open issue on GitHub with a pull request in under 30 minutes. So I'm just going to jump straight in. The pull request I'm going to be working on today is around adding port forwarding support to the Dask SSH cluster. In Dask, you can deploy like a distributed cluster for doing parallel computations using SSH. It's a really nice way of getting Dask onto machines that you might have SSH access to. You construct a cluster object, it SSHs into machines that you specify in the arguments, sets up workers and gets them talking to a scheduler on one of the machines. One of the issues that we had raised recently is that if you work in an organization or an institution that has quite strict firewall rules, you may be able to SSH into machines, but maybe that's all you can do in terms of connectivity to that machine. Dask expects to be able to serve on a couple of different ports so that you can connect to, the Dask client can connect, you can connect to the web dashboard, and things can talk to each other. So it's also quite common that you set up a cluster by SSHing into things, but also use SSH port forwards to get the traffic back locally. So what I want to do is instead of you having to manually handle those port forwards yourself, I'm going to bake into the SSH cluster the fact that it can handle those port forwards for you. So I'm going to just go over and have a look at the issues, something I raised the other day, and then we'll have a look at some code. So first things first, we will go and have a look at my page. So this page is the page for my channel. I'm also going to start the clock now. This is an open page and we can go to it. You can just go to constrain.dev and it'll take you to this repo. We have a 30-minute pull request project board where I have different issues that I'm thinking of working on in this channel and pull requests that I've raised and so on. Let's go into this issue. So this is support port forwarding in SSH cluster. So yeah, as I just explained, Dask by default serves on 8786 and 8787. And if it's not possible to access those ports, even if you can SSH to that host, SSH cluster isn't going to work. So it'd be really great if we could port forward back. And what I've kind of put like a little example code snippet in here to just say, a normal SSH cluster usage would just be this bit, right? You say import SSH cluster, and you pass it a list of the host names, IP addresses that you want to be pulled into your cluster. And I'm kind of proposing two new keyword arguments here. I'm not set on the names. Forward scheduler port and forward dashboard port were kind of the first ones I thought of. But what you're explicitly saying here is I want you to forward the scheduler port to this on my local machine, and I want you to forward the dashboard port to this on my local machine. And I don't think it should really matter where those ports are running on the other end. Because if there are multiple Dask clusters on a machine, then they'll get port conflicts and you'll get randomly assigned a high port anyway. So we're going to need to detect where it's running and do the port forwarding ourselves. I also had a quick look into what would be involved in this, and so I've linked through to like relevant docs pages. So we'll use those in a minute. So let's go into some code and actually find the bit of code that we need to modify. So this is in distributed. This is the Git, the Dask distributed repo. Just got checked out locally, master. If I go into deploy and SSH, we have our SSH cluster object. That's a SSH cluster object here. And this works by constructing instances of these other objects. So we have like a base class called process, which handles some kind of boilerplate stuff for managing SSH connections. And then we have a worker class, which starts a Dask worker on a specified address. And we have a scheduler class, which starts a scheduler on a specified address. And these literally, they use async SSH, and they literally SSH into a machine and then run the Dask code, basically. We construct this command as an array. And we use create process, which runs basically a bash command over the SSH connection. And it's quite configurable. There's a few things in here, but what I want to do is we want to open this connection, which happens up here, right? Self connection equals async SSH connect. We pass some connection options. But then I think if I have a look, I think I made a link to the docs. Is that the docs I'm thinking of? Yes, it is. So there's a function that you can call which just says forward remote port, and you say listen host, listen port, destination host, destination port. So we want to listen on localhost on whatever port we configure on the destination host and the destination port, which will be also. So the listen host and listen port are relative to the machine you're SSHing from. So this will be like my laptop in this instance. So I want to listen on localhost on my local machine on a port. And then the destination host and destination port are relative to the machine you've SSH'd into. So, if I have a random Linux machine that I can SSH into, from that machine's perspective, I want to also forward localhost and a port. I'm kind of forwarding from localhost on my laptop, and it's because you can do funky things like, say you have like a gateway jump server inside a network, so you can SSH to a machine, but the actual machine you want to interact with is a different one, and you can't SSH to that. You can do this kind of thing. You can forward ports, so I could SSH from my laptop to a remote machine, and then forward the port from another machine back through that SSH connection, as long as that other machine is accessible from the one I've jumped into. That was slightly in depth, but yeah, I'm going to look at setting this up. So I want to, I think this is a coroutine method which attempts to set up port forwarding from a remote listening port to a local port via the SSH connection, via the existing SSH connection. The request is successful. Return value is an SSH listener object we used later to shut down the port forwarding. So we care about that. That's fine. Remote forward remote port. This is all properties of an SSH client connection. Which I think is the thing that we're creating here. This self.connection, I think, is of type client connection. I don't know if there's any type hints in here. SSH client connection, yes. Okay. This creates a new connection. So what we want to have, we need. Let's start from the top. Let's start from the user API. So in SSH cluster, I'm gonna add these arguments kind of as I've named them. So what did I call those? Oh, I've not. Let's click back through to my issue. I named the quags forward scheduler port and forward dashboard port, but I'm not set on those. This is probably something I'll get flagged in review, and those are going to be equal to none by default, which will disable that by default. So if you want to do the port forwarding, you have to set some values here, and those are actually going to be integers because they're ports. So fine, those quags exist, and then we should probably update the doc string as well. I'm going to go like that and just copy those down here, and then it's going to be, just change that to optional, and then no, optional, and we're just going to say local port to forward the scheduler port to. That's not very descriptive, might change that. Local port to forward the remote dashboard port to. Let's put the word remote and the remote scheduler. Okay, that's fine. So we've got some of those. We should maybe include an example at some point. But then I want to set these in the options here. So this dictionary here, the scheduler dictionary, these options these basically get unpacked into the quags of the class. So if I look at the scheduler in it, we have address, connection options, quags, remote Python. And this dictionary here has, address, connection options, quags, remote Python. So this gets unpacked into that method. So let's just add these here as well. Oh no, I'm just gonna do some bad copy pasting into this section. So let's just make those like that. Don't care that they're integers, and they are just going to be themselves. So by default there'll be none, but they'll get passed through. So now, from a user API point of view, we have these two new quags with doc strings, so you know what they do. and then we'll pass that through to the scheduler object. So we get these forward scheduler port and forward dashboard port. And they're going to get unpacked as quarks. So I will copy those from here, and I'll come up to the scheduler class. And I'll also pop them in there. Black will probably reformat that for me now. Those are the same args that are coming in here. And then I'm also going to copy the doc strings because they are going to be the same. Like that. So that's fine. Those, and we should store them as well. So we're going to say self dot and self dot, and they're going to be equal to themselves. Like that. Okay, so now the scheduler class, once the SSH cluster gets instantiated, the scheduler class will get instantiated, and we'll have these ports forwarded all the way through to here. So now when we start the connection, we want to set up the port forwards. And we also want them to be torn down again. That only really matters in this class. Now the base class has like a close method here. What I'm going to do is we've got a start method in our NAS worker. In our scheduler, we have a start method. We don't actually have a close method because there's been no need to override it, but I'm going to do that. So that's, yeah. When close gets called on the scheduler, at the moment it'll just call close on this, but we also want to, let's do this as a to-do. To-do, close the port forwards. And here, this will be a to-do as well. To-do, set up the port forwards. And then the other thing we need to do is we set the address here, right? When we SSH to the machine, we run the Dask process, and then what we actually do is we read the log back from the scheduler process, looking for the line in the log that says where the address that the scheduler is running, and we set that to self.address. And this is how the cluster object knows how to interact with your scheduler, right? The scheduler class is responsible for making a scheduler somewhere, somehow, and setting a property of self.address. And then other things can come in and inspect that property of self.address and create RPC connections and interact with the scheduler. So under normal circumstances, if I SSH to a host A or something, this will get set to host A or the IP address of host A or wherever Dask sees its address. And then my local client and the cluster object will connect to that IP address of host A. But in the situation where the firewall won't allow that connection, and we want to go through these port forwards, we want this address to point to localhost. We want it to point to the port forward rather than to the remote host. So we need to do something in here to say, yeah, maybe we want to do that. I'm just thinking, we read through to this point to work out where the scheduler is running, because it comes out in the log. But also, one of the benefits of that is we know the scheduler is running because by the time it's got to that log message, it's ready to be connected to. So I don't know whether I want to wait or whether I should. Like what I could do, because we know this ahead of time, if we do the port forwards, we could do this as soon as we create the process. We could have if port forward self.address equals this, else port forward equals this. I actually think I want to do that because this is breaking here, right? If scheduler at inline this, do this, and then break. So we're actually breaking out of this infinite loop. What I'm worried about is a race condition, basically, is where we, if we don't have this while loop and we just call super start, if we create the process and then set the address to localhost and then thanks for commenting, JVRNDS. could do with a timeout in the while loop. We don't actually have one in this. It might be better practice to do so. Yeah, so I mean, because we are reading standard out here, this line here, we're reading in from standard error, actually, we're doing read line. This kind of is almost acting like a back off in this situation that, we read a log line, and then we kind of we go back around the loop. If that log line wasn't the scheduler address, we come back round and we wait to read another log line. And if there isn't another log line, then we just sit and wait here. And the Python async library handles kind of just sitting and waiting at this point. So we're not hammering trying to read a log line or anything. We could maybe do with a timeout, because if the scheduler fails for some reason and never ever logs a line that says scheduler at, async. This is all async stuff. If we never log this line, we're just going to be sat here in this loop forever. So maybe we could do the timeout. But what I'm mostly worried about is having introducing a race condition here. Because if I have if we've set up our port forward, so if either of these, if scheduler port is not none, then we can just do self.address equals localhost. This will probably be TCP, so that doesn't necessarily handle the right protocol. TCP that. I think we have to be Python 3.6 compatible here, otherwise I would use an F string, but let's use format template. So I do self.address equals this, and then go, oh, my keyboard's disconnected. Okay, sorry, I disconnected my headset instead of my keyboard. Let's try that again. Keyboard's back. Right, else this, right? So that wants to be in there. So if we have scheduled the port, we have forwarded the scheduler port locally, we set the address to the local port. Otherwise, we try and grab it from the log. But the trouble is, if we hit this, we'll immediately set this, and we'll move on, and we will call superstart, and there's going to be a race condition here because the scheduler might not be ready. We've only just spawned the process. We might then, in here, I think we try and create an RPC connection to it. So we might just immediately try and connect to it and fail. There might be some back off, but I think it might actually be more robust to put it in that while loop. So as soon as this reports that, I'm gonna put that in here. So as soon as we see scheduler at this, if it is local, we might even want to set up the port forward there, to be honest. Thinking about it. Because when we submit the when we run Dask scheduler here, this will try and run on some default port, 8786. But if that is occupied, Dask will fall back to using a random high port, and we want to kind of handle that as well. So I might actually say we don't want to set up the port forward here. We want to go through as normal and submit our scheduler. And then at the point of getting the address, we can go, oh, if we've said, can you forward the port locally, then we should actually set up the port forward and then set the address to that, and then call start. I think that makes most sense. And then we've got to close the port forwards here. So let's go back to my docs. Drop back down to where I was. So forward remote port. And that's connection. This is, if I say here, if I go await self.connect, is it connection? Yeah, self.connection. There we go. Dot forward remote port. And then we want to be localhost. Oh, actually, think about this even more. I need to get this, don't I? Because I need to actually get the address. So I'm gonna let it set the address to this initially. and then we're going to say we'll override it again. So if the forward scheduler port is that, because what I want to do is say I want to say host port equals self.address. No, I just want to do underscore port. I only want the port dot split colon. Okay, so we should. This would just give us the port, and we want to forward. This is listen port, listen host, listen port. The listen host is localhost. Listen port is this self.forward scheduler port. And then the remote, the destination host, whose name and address to forward connections to, is going to be localhost relative to the machine with SSH to, and then that port will be whatever the Dask schedule is running on. So that will be port. Now that I think actually I want to do something like self dot port forwards dot append and that, right? Because I think I want whatever object this gives me back, an SSH listener. Let's actually make that a thing. Port forwards. There's a list. Right, so we make a port forward here, and then set the address to the correct thing, and then that's fine. Yeah, I think that makes sense. So we'll get rid of that. And then we also need to close the port forwards as well. So in the close, we now need to do for port forward in self.port forwards. I don't know why mine autocomplete isn't working. We'll port forward in self.port forwards, and we want to close it. How do we do that? So sh listener.close. Is it a method or is it a coroutine? Oh, it's just a method. Okay. Yeah. That should be fine. So we should just say port forward dot close. Now just close that. We should maybe even say wait closed. Wait for the listener to close. Yeah. Yeah, let's do that. Let's go await port forward dot wait close. Wait closed. Wait closed. Wait closed. Like that. Okay. That is fine. And then we also, at this point, we should forward the dashboard port if that's been set as well. So let's say if when you run a Dask scheduler, let's just run it. Just make sure I'm in the right environment. If I go Dask scheduler, I can see scheduler at here, and then we've got dashboard at this. I'm not sure if the dashboard also runs randomly on a high port. It might do, but I'm gonna assume it doesn't. I don't know. Let's have a quick look. Limited for time, I'm aware, so just say port. Not import, let's just port. Give me all the word. Port. Oh. Scheduler. I'm just trying to see if I can find where the port is being run. Where the port is being set in the Bokeh application. I mean, if I search for 8787, you can give me all sorts of stuff from doc strings and things. Default 8787, dashboard address. That HTTP server, default port 8787. What is that? It's a subclass of. As the scheduler. Okay, I'm just going to assume 8787 and that it doesn't do clever things. I might be wrong. So if self-talk forward dashboard port, which is this, forward dashboard port, and we're going to say self-talk port forward append remote port. So this will be forward dashboard port, and that will be 8787. I don't know if that needs to be it. They need to be strings, or I guess they'll just be whatever. Yeah, I should maybe explicitly cast those just in case they get munged in some way. So that should be like an int of a port. And that should be an int of a port. That should be an int. This is, I guess, if you configure in your Dask config or something. I just want to make sure that if you put a string with 8786 in or whatever, we're passing the right things through. So we set the address as you'd expect, but then we're saying if forward the scheduler port, forward it locally and update the address, and if forward the dashboard port, then forward that locally as well. We may want to change how it works out the dashboard address as well, because I think the cluster.dashboard URL probably put in the wrong thing if we set this up like that. So might want to think about that as well. But I'll think about that in a minute. So those are running, that's fine. Close is going to close all of those out. We could actually gather. We could do like async io dot gather. No wait it. Oh wait. I am importing async io, aren't I? Well, I'm not. Okay. Import async io. So instead of sequentially closing each port, we can gather those, and we can say sort of that. If I do something like wait closed, I'm actually going to say p dot wait closed, or p in that, or p in that, close that out, get rid of that. Okay, so this is a neat little one-liner. So we're saying we've got a list comprehension here where we're saying for p in self.port forwards, so we'll get those objects, and then we're just calling p.wait closed, even though it's a coroutine. So this will end up being like a list of futures of calling this, and then we're going to unpack that list of futures into async.gather, which waits for everything, and we're just going to await async.gather. So this will concurrently close the connections. Just give a little bit of parallelism there. So, because it's like, closing a connection like that is an IO operation. So you're not going to be, it should be faster. I've got all that set up. I've updated everything. I'm hoping that might work now. So let's go into IPython. IPython. Oh, I really can't type IPython. Let's go from Dask.distributed import. Let's import SH cluster as it is, and then we're going to say cluster equals SH cluster, and I'm just going to say I want a scheduler on localhost. Let's make sure I can SSH to my own machine. I'm sure I can, but yes, I can. Fine. So if I SSH to localhost, and I just want our worker also on localhost, just to make sure the worker can connect. I'm just going to do that. This is a test actually, and we're just going to say cluster equals that, so it should SSH to my own machine. Right. Now if I go cluster, I have one worker which has picked up all the resources on machine. I'm actually going to import client as well, so I can submit some work, make sure it works. So C equals client cluster, and then I'm just going to import Dask array as DA. And then we'll go da.random.random. Let's just do a little thing of 100 by 1,000 in chunks. 100 by 100, so we just get 10 chunks dot mean dot compute, just to force it to do something. Right, okay, give me an answer. That ran on my cluster, and that all worked happily. So I'm going to exit my session, which should kill that. I'm actually just going to check. I'm worried that maybe there is a bug in this. It's left the cluster running. I just want to double check that it hasn't. Let's just set it up again. Yeah, I think that's fine. Yeah, right. So I'm going to come out of here. And then this is all going to be a bit weird because I'm going to port forward to my own machine. Oh, I've got 50 seconds left. I think I'm probably not going to make the pull request in time, but I'm pretty close as long as this works pretty easily. So what I need to do is call forward scheduler port. And I'm going to forward scheduler port to, I don't know, 86, sorry, and forward dashboard port to 58787. Let's make sure that ooh, too many values to unpack, expected 2. Lovely, that's annoying. I think then what I want to do is, it might be getting an IPv6 address, that might be what it is, so I'm going to go like that, and that's a bit of an anti-pattern. But let's try doing that. Python, H cluster. We got to that point, right, where it picked up that log line. Another literal for int TCP. Scheduler at this. Oh yeah, -1. Silly me. Right. Ooh, time's up, or just times. I really need to fix that. Apologies if you have watched me a few times. I need to make the text smaller when I get to the end of my timer. Right, let's try that again. Hooray! Okay, that seemed to work. If I do cluster, I have a cluster. I'm going to import Dask array and do my little array calculation just to make sure that. Right, and what I'm actually going to do is I'm going to I ran the dashboard on this 587.87. So let's go to my browser and go to localhost 587.87. Hooray! The Dask dashboard is running on my forwarded port. I assume it's also running on regular 87.87. Yes, because I'm just SSH to my machine. But in theory, that 87.87 would be on some remote system. 587.87 is being port forwarded back here. And then if I'm going to run this, I'm actually going to give it a bit more work to do this time. Let's say 1,000 by 1,000 by 1,000. And I'm going to give it chunks of 100 by 100 by 1,000. At least it's got a bit more to do. So if I run that and head to my dashboard, I should see some things happen. Oh yeah, I haven't created a client. Yes, that's why. Client. Distribute. Yes, okay, my dashboard is doing something. Good, okay. So that's fine. My connection is being SSH port forwarded. My dashboard is being SSH port forwarded. Ignoring those arguments also works. That's fine. So I could now SSH into like a load of machines if I've got access to like 10 machines. That would be fine. And then I can run my workload and I can just kind of poke through the firewall. So I'm going to stop that and let's very quickly try and raise this pull request so I don't go too much over time. Come on, let's come out of that. So let's check out a new branch. And this will be SSH port forward. And then let's add everything and commit it. So we say add support for port forwarding in SSH cluster. Cluster, right. Yep, and then git push that. And then we're going to open a pull request. Yeah. I love that it gives you that link now. It's so easy. Just have a quick skim over my code, make sure the changes are what I expect. We add these quarks to SSH cluster, document them, and pass them forward to the scheduler. Then the scheduler, we take those quarks in, assign them, and then if they have values, we set up the forwards and redirect the address. And we handle closing them, and that's it. Okay, that's good. What was the issue number? 3881. Closes 3881. Added forward scheduler port and forward added forward scheduler port and forward dashboard port quarks to SSH cluster to automatically handle port forwarding. This means you only need access to port 22 on the remote system, and you'll still be able to connect to the cluster. Lovely. Not set on the quark names. Happy to take input on those. Yeah, let's create a pull request for that. I could maybe add a little test as well. That'll be very similar to the test that I just did, so I might just have a quick peek at that as well. I know I'm over time now, so but I've got my pull request. Let's just before I do that, I've got a pull request raised, so I'm gonna go back to my project board. I'm gonna say raise pull request. I've raised this pull request. Hooray! So we'll leave that there. There's been no movement on those other two pull requests that I've raised, so I won't go into those. Yeah, so I'm going to say I'm done. I've raised my pull request. One nice thing to do would be add test, which I'm going to stay on and do that now quickly. But if you want to drop off, I don't blame you either. So let's go and do that anyway. So in distributed deploy tests, we have test SSH. And this, I think it does literally just SSH locally and make sure that things are up. Test quarks, test yeah. List of connection options raises. Okay, I think I basically want to copy the top one. Maybe not necessarily the top one. Just want I want a very basic test, which just SSHs locally. What's this doing? Test inherited by subprocess. Okay, we don't really want that. Unimplemented options. I want something with a client that does something. I'm just gonna copy the basic and maybe trim it a little bit. So let's copy the basic and let's say test port forwarding. I'm going to move this to the bottom as well because just because it's new doesn't mean it needs to be there. Test port forwarding. So SSH cluster ×3 connection options, known host, that's fine. Asynchronous true, visual ports, whatever. So this should be the forward scheduler port and forward dashboard port. I'm going to try and set them something obscure. So I can set it the same actually. Let's go 58786 and 58787. That's fine. And then we will assert that there's two workers, connect the client, submit some work. I'm not actually that worried about these two. I feel like they've been tested already. So we're gonna submit some work and assert that the work is submitted. And that should be fine. Actually, what I'm going to do is I'm going to add a test to say, let's go back to my IPython session. And I'm just going to make this cluster for myself again with my local port forwards, because I want to see if I do. Ooh, here it is. Because I've left something running. If not, line.strip, work if I had to start. I think I might have got myself in a funny state. Let's try going like that. Yeah, look, I do seem to have. That's what I was worried about, is leaving a scheduler running somewhere by accident. Let's go back into our Python again. Import that. Yeah. Okay, I had a weird scheduler running. That's fine. So if I go cluster, I do cluster dot address. No. Dot scheduler dot address. Yeah, that's what I want. So in my test, I want to say assert the length of that is that, and then I want to say assert 58786 in the address. I want to make sure that it's picked up that new address. So that's fine. I've added a test. It's going to connect through the SSH port forward. We're going to assert that it's got a different address. And then we're going to connect to it. That's fine. So let's add that as well. Yeah, see, this is what happened before, right? Is I Control-C out of IPython and we just hung here. It might be waiting to close the port forwards or something. Let's kill this again. I reckon the Dask. Oh, okay. No, we just got in a weird state. So I've added my test. So let's go git commit add test, and then we'll push that up as well. Git push. Okay, so that's a more robust PR, more likely to pass review, because we had a little unit test in there as well that just makes sure that things work as expected. We've got our new arguments, we're asserting the address has got that in it, and we just make sure that's fine. Okay, there we go. Pull request in not 30 minutes. We're at about 40 minutes, so that's not too bad. I actually got a pull request basically within time, but then I've been tweaking it at the end. So thank you very much for sticking around. I hope you enjoyed seeing me work on Dask. I am continuing to do this kind of streaming. Let's come back over here. Yeah, I'm continuing to do this 30-minute pull request. I'm trying to do it a few times a week, maybe 3 times a week. And I think it's going reasonably well so far. I've raised a bunch of pull requests. It's kind of making me do little odds and jobs. So if you have any feedback, please come and find me on Twitter. I should probably link to where that is. It's _ Jacob Tomlinson. If you head to constrain.dev, which is the webpage I first started on, there's like links to everything from there. So thank you very much, and I will